Okay, my apologies to anybody watching this video. Our smartboard document is going to look different. If you want to look at this and copy these shapes down at all, you sure can, but our smartboard document, this is a PDF. Our smartboard document doesn't print off as nice. I don't know why. Uh, Maybe there's a setting within our smartboard printing device that allows for better resolution. But anyway, this is what we get. Um, so here's what we're going to do. We want to look at f prime of x. We want to identify intervals of increasing and decreasing concavity, local max, local min, and inflections. So this is also f prime of x over here. Okay. Now, this is tricky, and this is without a doubt very, very important for the AP exam. You will have a number of questions that will be related to this. I would estimate at least 6. Okay. So increasing. Can somebody tell me, as I look at this graph right here, does it look like the graph is increasing or decreasing right here? It looks like it's decreasing because f prime of x is decreasing. But the question is, what about f of x? See what I'm saying? What about f of x? So when we're asking about increasing, decreasing, concave up, concave down, we're asking about not the derivative, but the original. And so what we have to do is we have to look at the definition. The definition of increasing is where f of x, or f prime of x, is greater than 0, correct? I am looking at the graph of f prime of x. Where is this graph greater than 0? Wherever it's above the x-axis. So from negative infinity to negative 5, union with 2 to 8. It is decreasing wherever f prime of x is less than 0. Where is f prime of x less than 0? Negative 5 to 2, 8 to infinity. Very good. I can also now determine local max and local mins. Okay? The local max occurs where the first derivative changes from positive to negative. So, is the first derivative positive or negative right here? It is positive. I'm above the x-axis. So I change from positive to, so therefore at negative 5 I have a max. A min is where I change from negative to positive. Am I negative or positive right here? I'm negative. I'm below the x-axis. And I change to positive. I'm above the x-axis. So therefore there is a min at then I change from positive to, so therefore I have a at. Now, what do you think somebody might have listed the location of the local min? Yeah, -1, -4 would be, what a lot of people would list. Now, we only have the x values. We cannot determine a y value. We don't know what the y value would be. And here's why. If I say f prime of x is equal to 2x, does anybody know what f of x would be equal to? What do you take the derivative of? X squared. But it could be x squared. It could also be x squared plus 5. You don't know. Both have a derivative of 2x. So therefore, you don't truly know the location. So we can't determine that, or the y value, but we do know those. Okay, concave up and concave down. Little bit trickier in this situation, but we want to determine where f double prime of x is greater than 0 and where f double prime of x is less than 0. Okay? F double prime of x greater than 0. So in order to see f double prime, right now I'm looking at f prime. What would I do to show f double prime? What would I sketch on here? How do I sketch the derivative on here? Whenever you see a curve and you want to draw the derivative at a point, you draw a tangent line. So this line right here represents the second derivative. Okay? the derivative of the first derivative, the second derivative. At this point, is the second derivative positive or negative? Is the slope positive or negative? So therefore, the second derivative is negative. So it is concave down. How about here? Positive or negative? The slope of that tangent line is negative. The second derivative is negative. So I'm still concave down. What is the value of the second derivative right there? 0. So it changes from concave down to concave up. So therefore, it is concave down from negative infinity to what? Negative 1. And it's concave up from negative 1 to, let's see, I got positive slope there. I got positive slope there. So finally at x equals 6, it changes. And then it's concave down from. Now, the definition of an inflection point is where it changes concavity. What were the 2 points where it changed concavity? Good. Question. So right here, it is increasing from negative infinity to negative 5 because it's above the x-axis. But the second derivative, we find the second derivative by drawing tangent lines to the first derivative. And as long as the slope of the tangent lines is negative, and right here, the slope of the tangent lines are still negative, so it's still concave down. When I draw tangent lines that have slopes that are positive, then it's concave up. So as I draw in red, concave down, because all of those slopes are negative. Concave up with the blue. Does that help a little bit? I don't pretend that this is easy. This is the first time we see it. Generally, it gets a little confusing right away. Try this one on your own. Okay, try that one on your own. We just want to do the next two, but think through it how we did this last one, and I think you'll do a great job. Okay, let's check what we got here. Okay, pause wherever you're at. Do you have increasing where it's above from negative 8 to positive 2? And then from 10 to infinity. It's below from negative infinity to negative 8. And then from 2 to 10. That's where it's below. Okay. So therefore you have a local max where it changes from positive to negative, and that was at 2. And local min where it changes from negative to positive. That'll be from negative 8 to 10. I'll do what I did last time, which was the blue will be where it's concave up. Concave up wherever the derivative of the derivative is positive. Red is concave down. Or in other words, wherever the first derivative is increasing, it will be concave up. Wherever the first derivative is decreasing, it will be concave down. And so therefore I have my intervals of concavity, and I have inflection points wherever it changes. So x equals negative 6, negative 4, negative 1, 5, 7, and 9. Okay, one more example, then I'm going to give you your short assignment. Okay, we're going to look at this last one, f double prime of x. So instead of looking at f of x, we're looking at f double prime, double prime, double prime. So what tests do we use to determine increasing and decreasing? First derivative or second derivative? So we cannot tell anything about increasing or decreasing by looking at the second derivative. We also do not know the local max or local min. But we can tell about concavity. Concavity happens where f double prime of x is greater than 0. If I am looking at f double prime, where is f double prime greater than 0? Above the x-axis, and that's from negative infinity to negative 7, union with 4 to 9. Concave down, where f double prime of x is less than 0. And that would be from negative 7 to 4, union with 9 to infinity. X value, positive infinity. Finally, inflection is where it changes concavity. Okay, excellent guess, but that is not what we want. The second derivative changes sign at negative 7, positive 4, and positive 9. So it's different depending on whether you're looking at the original or the first derivative or the second derivative, correct? That's what makes it a little challenging. So your assignment is, it's like I erased it, 4.3, I handed out your pages, page 247, numbers 5 through 8. I'm pretty sure. Let me just check and see. Yep, 247, 4.3, numbers 5 through 8. And it's just like this. So not much to your assignment today. Make sure you really figure out yesterday's and oh yes, your checkpoints, if you could please just set them up by Hannah's desk on the corner there, that'd be great. Thank you. See you tomorrow.